Hello students, today I want us to consider paper 6, probability and statistics 1, the code being 9709/61. It was taken in May-June 2010. This is GC, that is General Certificate of Education, Advanced, AS and A-Level. And so the question of interest is question 3. The random variable X is the length of time in minutes that Janon takes to mend a bicycle puncture. X has a normal distribution with mean, mu, and variance days. It is given that probability that X is greater than 30, 0.1480, and probability that X is greater than 20.9 is equal to 0.6228. Find the mean and the standard deviation. That is 5 marks. So we proceed to find the answer as now the question here again is that probability, okay, we are given that the mean of a normal distribution is mu, and the variance is and the variance is that standard deviation squared. Then we are told that probability that X is greater than 30 is equal to 0.1480, and probability that X is greater than 20.9 is 0.6228. 0.6228. Find the mean and the variance. Find the mean and the variance. Now, this first expression will be probability that X is greater than 30 is written as probability that Z is greater than 30 minus mu over standard deviation, like that, and we are seeing that is equal to 0.1480. That's one. Then two, probability that X is greater than 20.9. 20.9 will be given by this, that Z is greater than 20.9. Z is greater than 20.9 minus mean over the standard deviation, and that we are given to be 0.6228. Yes, those are the two expressions we are given. And then it simply means that all that we are given are the probabilities. This is the probability, this is also a probability. So for us to find the value of mu, that is the mean, and the standard deviation, we will need to find the value of Z that corresponds to this probability. And we also need to find the value of Z here that corresponds to this probability from our table as follows. Then we can plug it in to work out the value of mean and variance. So the Z values are, the Z value that corresponds to X, that corresponds to probability that X is greater than 30 is the probability 0.1480. So for us to get this, the corresponding probability, we'll have to subtract 0.1480 from 1. That will give us 0.8520. 0.8520 we check within the body, because now this is the probability. So within the body here, we set out to look for, we set out to look for 0.8520, 0.8520. So we come and set layer. Here it's 1.04. 1.04. And when we are at 1.04, we are less with 12 to get to 2, because 0.8520. So in that case, we come here, we look for 12, we find it under 5. So in other words, our Z value is 1.045, 1.045 plus or minus. Secondly, we have that probability that X is greater than 20.9 is 0.6228. So 0.6228 is another probability, but that now we check directly under the table within the main body, 0.6228, 0.6228. So we find here we have 0.6217, but we want 0.6228. So that's 11. We need 11 more. We find that 11 under 3. And so we have 0.313 as the reading, as the corresponding Z value. So those two values, we pick them and use them in our calculation as follows. Yeah, as we have seen, the Z values are, for the first case here, for this particular case, the Z value is, for that first case, the Z value is, we take it plus or minus 1.045 as we have seen. And for this second case, the Z value is, this second case, the Z value as we have seen, we also say it's plus or minus 0.313 as we have seen from the tables. So this will now allow us to specify it as follows, that our first equation is, if Z is this, it will be 30 minus U over this is equal to our Z value, which is 1.045. That gives us our first equation. Our second equation will be given by 20.9 minus mu over the standard deviation, which gives us it is plus or minus 0.313, plus or minus 0.313. So because of this, we adopt a minus. So we say minus 0.313. Well, we could try plus as well. We could try plus and see the value that we get, but conveniently, the negative sign works it out. So if you make this the subject, that will imply then that 30 minus mu is equals to 1.045 standard deviation. First equation. Second equation is that 20.9 minus mean is equals to minus 0.313. That's the second equation. So you have a case here of two simultaneous equations, and you can solve using either method. And once you do that, I'll not get into that now because you should be knowing at this point. So that is if you solve them, then you, using any method, be it substitution, elimination, even if you choose graphical, whichever way. So that will give us a mean of 6.70 and a standard deviation of 23.0. It's the mean is 23 and the standard deviation is 6.70. So those are the answers. Hit that subscribe button so that you get updated with the latest releases. Thank you, and see you in the next video. Now let's consider how our graphs look. We see that the mean, this is a normal distribution. The mean is 23, and the standard deviation is 6.70 as we are given. But then we were told that probability that x is greater than 30 is 0.1480. So we want to ascertain that and also see how the curve looks like in that case. So probability that x is greater than 30 will be given by, if you look at our curve, this graph here with a mean of 23 and a standard deviation of 6.7, we realize that it starts stabilizing at around 46, moving onwards. So it means any value picked beyond this will be, from here the probability will already be stabilizing. So by picking any value bigger than this, then it makes no harm. So if I put here 30, it means that probability that x is greater than or equal to 30, or x is less than a value that I may pick, say 60 for my case. So in that case, because I know 60 is way beyond this, and so I'm safe. So if I press that, then I find that that probability that x is greater than 30 is indeed given by 0.1481. And the one we are given, that's an approximation, but the one we are given is 0.480. So that's difference, the difference in margin may be as a result of the fact that in the question it is strictly greater than, but here we give an option of greater than or equal to. Alternatively, we can also check to find out what happens when it is 20.9. So when it is 20.9, we change that to be 20.9. So we want the probability that x is greater than 20.9. We press that, then we see that this is 0.623, which is almost, which is actually the probability value that we are given if you round it off. So the area of the curve in that particular case is when x is greater than 20.9 is from here going this end. So it's the shaded part. And for the case where we had 30, let me just, okay, yeah. For the case where we had 30, then we had 0.1481 and 0.1481. That then means that we are considering probability that is greater than 30. So from here, it is the shaded region. So that is that. I hope you enjoyed the video. Kindly hit the button below your video, subscribe, like, and comment. See you in the next video.